Welcome to day 11 of Daily AI Wizard, my incredible wizards. I'm Anastasia, your super excited AI guide, and I'm absolutely bursting with enthusiasm today. If you found this lesson helpful, please give it a thumbs up, subscribe, and hit the bell for daily lessons. Have you ever wondered what powers machine learning to solve problems like magic? We're about to unlock the secrets of ML algorithms, the brains behind the magic, and it's going to be an amazing journey. You won't want to miss a second of this, so let's get started. I've brought my best friend to say hello. Machine learning algorithms are the stars of today's lesson, and I'm so excited to share what they are. They're sets of rules or steps that solve problems, guiding the model on what to do. In ML, they learn patterns from data to make predictions, like figuring out house prices based on features like size and location. These algorithms are the brains behind AI's magic, making it possible to solve complex tasks. I love how they turn data into intelligence. Let's explore the types of ML algorithms, and I'm absolutely thrilled to break this down. There are three main types. Supervised algorithms learn from labeled data, unsupervised ones find patterns without labels, and reinforcement algorithms learn through rewards and trial and error. Each type has its own unique magic, solving different kinds of problems in AI. This diversity makes ML so powerful and exciting. I can't wait to dive deeper into each one. Supervised learning algorithms are up first, and I'm so pumped to share their magic. They use labeled data, which means they learn from features and their corresponding labels, like spam or not spam for emails. Examples include linear regression for predicting numbers and decision trees for classification tasks. They're perfect for tasks with clear answers, like detecting spam emails accurately. I love how supervised algorithms make predictions so straightforward. Unsupervised learning algorithms are next, and I'm so excited to uncover their secrets. They work with no labels, just features, to analyze and find patterns in the data on their own. Examples include k-means clustering, which groups similar data points, and PCA, which simplifies data while keeping its essence. They're perfect for finding hidden patterns, like grouping customers by behavior. I love the magic they bring to discovering the unknown. Reinforcement learning algorithms are up, and I'm so excited to share their unique magic. They learn through rewards and penalties, figuring out the best actions by trial and error. Examples include Q-learning and deep Q networks, which are great for complex tasks like teaching a robot to walk by rewarding good steps. This approach mimics learning through experience, which is so fascinating. I love how these algorithms adapt and grow smarter over time. Choosing the right algorithm is key, and I'm so thrilled to guide you through this. It depends on the problem, classification, regression, or something else, and the type of data you have, like labeled, unlabeled, or reward-based. You should also consider the data size, the speed you need, and the complexity of the task at hand. Experimenting with different algorithms helps you find the best fit for your project. I love how this process feels like solving a puzzle. Evaluating ML algorithms is so important, and I'm so excited to share how we do it. We use metrics like accuracy, precision, and recall for classification tasks to see how well the algorithm performs. For regression, we might use mean squared error, or MSE, to measure prediction errors. Cross-validation, testing on multiple data splits, ensures consistent performance across datasets. This step confirms our algorithm is up to the task. I love seeing the results. ML algorithms come with challenges, but I'm so determined to tackle them. Overfitting happens when the algorithm memorizes the data, failing on new examples, while underfitting means it learns too little, missing key patterns. Some algorithms have high computational costs, slowing down training on large datasets, which can be frustrating. Choosing the wrong algorithm can hurt performance, so we need to be careful. I'm passionate about overcoming these hurdles to make ML shine. Here are some tips for working with ML algorithms, and I'm so thrilled to share my wizard wisdom. Start simple with algorithms like Logistic Regression, which are easy to understand and effective for beginners. Tune hyperparameters, like learning rates, to improve performance and get better results. Use cross-validation to ensure your algorithm is reliable across different data splits, avoiding surprises. Experiment and learn. It's a magical journey, and I know you'll love it as much as I do.